Building a robot that thinks and acts like us, that's not just science fiction anymore. It's the very real challenge of physical AI. Today, we're going to do more than just talk about the idea. We're actually going to unlock the blueprint, a real step-by-step guide to bringing artificial intelligence into our physical world. Let's dive in.
So, this is the big question, right? We've created these incredible AIs that live up in the cloud, mastering language, logic, you name it. But how do we break them out of that digital box? How do you give a mind like that hands to actually manipulate things, eyes to see, and feet to navigate our messy, totally unpredictable world? That right there is the whole point of physical AI.
And the answer to that question? It's all about physical AI, or what some people call embodied intelligence. Look, this isn't just about writing smarter software. It's the actual science of giving AI a physical body, one that can perceive what's around it, reason about what it's seeing, and, this is the most important part, act within our world.
Okay, so with a goal that huge, where do you even begin? Well, you start with a blueprint. And right now, we're about to lay out a clear 4-part framework that'll take you all the way from just a collection of parts to a smart, functioning machine. Here it is. These are the 4 foundational pillars of our build. First, we're going to construct the nervous system. Then, we'll create a safe virtual playground for it to learn in. After that, we actually forge the AI brain itself. And finally, we teach that brain how to see the world and, do stuff. Let's get started with step 1.
All right, first up, the nervous system. A robot's brain is completely useless if it can't talk to its motors, its sensors, its cameras. The go-to solution for this, the industry standard, is a really powerful open-source framework called ROS2.
Think of ROS2, that's the robot operating system, as the robot's central nervous system. Now, it's not an OS like Windows or anything. It's more like a super flexible framework of drivers and software that basically creates a seamless data highway between all the parts. Without it, you just have a very expensive pile of parts. With it, you've got a unified, responsive body.
So, we have a nervous system. That's great. But you don't teach a toddler to walk by putting them on a tightrope, right? Before this robot ever takes a single physical step, it needs a safe place to learn and, more importantly, to fail. And that's exactly where we build its digital twin.
And let me tell you, this is an absolute game changer for development. In the real world, if your robot falls, that could mean weeks of repairs and a lot of money. But in a physics-based simulation, something like Gazebo or Unity, you can have the robot fall over 1,000 times in one afternoon, tweak the code, and just hit reset. It allows for a speed and scale of learning that is just impossible with physical hardware alone. Okay, we've got a body, and we've got a virtual gym. Now we need the brain. And this isn't just about lines of code. It's about creating actual intelligence. For a task this big, developers often turn to really powerful robotics platforms like NVIDIA Isaac, which gives you all the tools you need to build and train sophisticated AI models just for this kind of thing.
This is the absolute core of its intelligence. The AI brain is what takes in that constant flood of data from all the robot's sensors. We're talking camera feeds, joint positions, tactile feedback, and translates it all into a coherent understanding of the world. It's how it learns to identify objects, predict what might happen next, and choose the best action to reach a goal. A brain is pretty useless if it can't see the world or act on what it decides. So the final piece of our puzzle is connecting that AI brain to its senses and its ability to move. And this is the domain of something called Vision Language Action Systems, or VLAs. This is really how these 3 things come together to link what the robot perceives with what it does. Vision lets it scan a cluttered room and find one specific object. Language allows it to understand a totally normal command, like, hey, pick up the red ball. And action, that's the final crucial step, translating that understanding into the precise sequence of motor commands it needs to actually go and grasp the ball. Okay, let's just take a quick step back and look at the toolkit we've put together. We've got the ROS2 nervous system for all the communication, the digital twin for safe training, the AI brain for intelligence, and these VLA models for perception and action. We've basically assembled all the individual pieces. Now, it's time for the final challenge, putting them all together into a single autonomous being. And this brings us to the grand finale, the capstone project, the mission that integrates every single thing we've just talked about, building a truly autonomous humanoid. This is the ultimate goal here. And we're not talking about a factory robot that just endlessly repeats some pre-programmed path.
No, we're talking about a machine that can operate autonomously, perceiving its environment in real time, making its own decisions, and completing complex tasks, all without a human pulling the strings. This is where it all comes together. You bring all four modules into play. The ROS2 nervous system is the foundation. You test and refine every single behavior over and over again in the digital twin. And finally, you deploy that fully trained AI brain into the physical robot, empowering it to act all on its own in the real world. So that's the journey. It's really about taking these distinct, incredibly complex modules and weaving them together to create something, well, something more. It's about transforming a collection of hardware and software into an intelligent, physical being that can actually exist and act in our world. So, we've laid out the entire blueprint for you, from the very first connection in the nervous system to the final autonomous action. The tools and the pathway are honestly clearer than they've ever been. So the only question left really is, what are you going to build with it?